Methane is the second most influential greenhouse gas, and its concentration in the atmosphere is rising and even accelerating right now. NOAA keeps close track of this, and in 2021, methane increased by 15 parts per billion, and in 2022, increased again by another 18 parts per billion, and those are both records for yearly increases.
Good evening, everyone, and welcome to Environmental Coffee House. I'm Sandy Shellis, and hi, Jennifer Hynes. It's been a while. It is wonderful to have you back. What's happening?
It's great to be here. Oh, yeah. Well, we've got a great show lined up tonight. I'm so excited to be here with you tonight to go over this. But methane has been rearing its head, so we're taking a little bit of a dive into methane. So the first one up is from University of Wisconsin-Madison News, so a school newspaper. New research finds boreal Arctic wetlands are producing more methane over time. And then we'll just take a quick look at the Nature article that gave rise to that article indeed. And then we're going over to earth.com. Arctic lakes produce less methane than previously thought, so potentially some good news for the Arctic. Then we've got something from Alaska and Arctic Climate Newsletter, March 2024, Arctic Sea Ice Update. So we're going to dive into the Arctic sea ice and all the different things going on there. And
videos.
Yeah, then we have a video. Sandy made a video. Very good one.
No.
And then, wait.
Good.
Polar vortex is spinning backwards above the Arctic after major reversal event.
And
True.
It's not the ice cream cone. See?
Yeah.
The polar vortex in the middle of it.
Oh my. So net Sandy, that is it, and that's where we are going.
We've got
tonight.
A busy show. So what we decided to do was we're going to play a video to start. I didn't make this. It's just something to get us ready, and but I didn't make it. It's cute, and it'll just give a little bit of a discussion about what we're talking about tonight. Yeah, we've got quite a few interactive things, so hang on.
Around the world, countries are working together to reduce greenhouse gas emissions and slow the rate of climate change. Commitments to reduce emissions, such as the Paris Agreement and the Global Methane Pledge, are vital. Methane, which is produced by the decomposition of organic matter in the absence of oxygen, is a powerful but short-lived greenhouse gas. And as they are significantly waterlogged, inland wetlands in particular produce large amounts of methane. However, not all methane emissions are equal. Natural methane emissions, such as those from natural wetlands, have always been part of the global carbon cycle and climate system. The methane produced by natural wetlands does not contribute to the rapidly increasing global temperatures generated by humans. It is human activity, such as fossil fuel production, agriculture and waste decomposition, that has resulted in the most harmful methane production and has had the greatest impact on climate change. Global efforts to reduce methane emissions must take account of the multiple benefits that natural and restored wetlands offer. Wetlands store large amounts of carbon in the soil and are important carbon sinks. They even store more carbon than forests. But more than 1/3 of wetland ecosystems have been lost since 1970. The human-inflicted loss and degradation of wetlands leads to greater global warming caused by higher carbon dioxide concentrations in the atmosphere. And as CO2 has a long atmospheric lifetime, once it is emitted, it will remain there for hundreds of years, continuously contributing to the increase of global temperatures. Methane, on the other hand, has a short atmospheric lifetime and will disappear from the atmosphere within a decade. Whilst restoring wetlands can raise methane emissions temporarily, best practice restoration reduces this risk. Restoring wetlands greatly reduces the carbon dioxide emissions of those that have been degraded and enables the continued sequestration and storage of carbon in the soil, reducing the total warming potential. The carbon benefits of protecting and restoring wetlands therefore far outweigh their methane emissions. Global efforts to reduce emissions must start by addressing human activities and human actions and their impact on the climate. Together, we can act to conserve and restore our natural wetlands. To learn more, download our technical report.
Oh, well, I liked it. So
Yeah, she had a beautiful voice, as the
Yeah.
comments said. She
Yeah.
can say anything, and it's like all good.
And I think wetlands restoration is a wonderful thing. So, all right. Well, let me just say hi to the moderators. Kim, thank you, and Obsolete and Looney, and thank you for being here, everybody. Just great to see all of you. But we got a busy show, so we're going to get started with what we need to do here. And that is get up our articles. And here we go.
And I
Jennifer-
believe that this is Void's alma mater. I saw that in the comments that he said he went to
yeah.
University of Wisconsin,
Yes,
Madison.
yes.
So this is his old school newspaper. Yay.
Yeah, he wrote for it too. Yes.
Oh my, well,
It's
he'll
great.
love this. Okay, cool. So here we go, guys. New research finds boreal Arctic wetlands are producing more methane over time. Scientists have been measuring global methane emissions for decades, but the boreal Arctic, with a wide range of biomes, including wetlands that extend across the northern parts of North America, Europe, and Asia, is a key region where accurately estimating highly potent greenhouse gas emissions has been challenging. Wetlands are great at storing carbon, but as global emissions increase, they are warming up. That causes the carbon they store to be released into the atmosphere in the form of methane, which contributes to more global warming. Now, researchers, including the University of Wisconsin-Madison's Min Chen and Fa Li, have developed a new model that combines several data sources and uses physics-guided machine learning to more accurately understand methane emissions in the region. The improved model shows that these wetlands are producing more methane over time. Quote, wetland methane emissions are among the largest uncertainty in emissions from natural systems, explains Chen, a professor of forest and wildlife ecology in the University of Wisconsin-Madison College of Agricultural and Life Sciences. There are bacteria that live in the soils under the water of wetlands. That's the perfect limited oxygen environment that's suitable for methane production. What problems are researchers trying to solve? Currently, models used to quantify methane emissions in the boreal Arctic wetlands don't agree on how much of the gas is being emitted and whether the amount is increasing over time. Previously, to help moderate emissions of carbon and methane, a collaboration of scientists created the Global Methane Budget under the Global Carbon Budget, which they hope will inform policymakers. However, Chen says if scientists want to quantify the global methane budget accurately, they need to have more certainty in how much methane is being emitted by these wetlands. So, he and other researchers collaborated to build a more accurate and reliable model to better understand the region's methane contribution as global temperatures rise. Why do scientists need more information on emissions from these wetlands? The boreal Arctic holds up to 50% of the world's wetlands. With rising global temperatures, the region spends less time frozen over the plants and microbes that are growing and productivity for longer periods of time. This creates conditions for more methane emissions. How does the new model help? The team created the largest data set yet for the region, which allowed them to develop a more accurate data-driven model of the boreal Arctic's wetlands methane emissions. Chen says the previous models did not account for the full complexity of the physical and chemical processes at play, such as substrate availability, microbial activity, and other environmental conditions that influence methane emissions. This is because they relied on partial emissions data collected from either a network of towers around the region or from chambers that take readings from the ground and surface on the water. Though the towers are a gold standard for measuring the flux of greenhouse gases between land and atmosphere, Chen says, in the boreal Arctic, they're mostly not located close to the largest methane emitters in the region. Meanwhile, the chambers are near these hotspots. Whereas prior models then only had one part of the complete picture and had to extrapolate to estimate the full picture, the new model combines data from both tower and chamber sources.
Mm-hmm.
The scientists also used artificial intelligence to create additional constraints that better account for how environmental variables like precipitation influence methane emissions.
Mm-hmm.
So this is an interesting graph, Sandy. Did you want to take a quick pause here?
Yeah, this is where we're gonna. Yep, we have a video to show you guys how the scientists measure how they do all of this. So hang on a second, and we.
Have you ever wondered how scientists measure CO2 and greenhouse emissions from local ecosystems here on Earth? Well, one way is a well-defined scientific method known as eddy covariance. Not that, Eddy. Eddy covariance is how we measure an ecosystem's breathing. It's the CO2 and other gases that are exchanged between soil, vegetation, and the air in an ecosystem. The data it provides helps scientists to develop models that forecast long-term trends in CO2 and greenhouse gases, much like the National Weather Service forecasts the short-term weather. This data will allow policymakers to draft legislation to address pressing issues and improve people's quality of life. Eddy covariance quantifies gas fluxes or changes by directly measuring the movement of gases, like CO2, between an ecosystem and the atmosphere. To simplify it, let's look at both words. An eddy is a circular motion of air created by temperature fluctuations. At night, without the sun, the air is cool and relatively stable. With the rising of the sun, the earth and air temperature begins to climb. This constant night and day fluctuation creates the wind we feel and the eddies of air that scientists measure. Covariance has two parts, co meaning together, and variance meaning change. This means simultaneously measuring the differences between the concentration of a gas and the direction of the swirling wind. Eddy covariance is primarily measured by two pieces of high-tech gadgetry mounted on tripods and towers above areas of interest, like forests, lakes, or agricultural areas. The anemometer measures wind speed and direction. The infrared gas analyzer measures gas concentrations in the air. The data are collected simultaneously thousands of times per minute. The wind and gas concentration data go into a complex series of equations that, after several assumptions, yield estimates of the movement of gas into or out of an ecosystem. Two types of observations are primarily used to approximate the gas exchange. Imagine we place a box over the ecosystem. The gas moving in and out of the top of the box is calculated as fluctuations around the mean. The gas accumulated inside the box is calculated from the trend of gas concentration measurements in that area. When calculated over time, we can see trends that reveal how much CO2 and other gases are being reused by Earth's organisms and how much is released into the atmosphere. To really simplify, the system works by measuring how many gas molecules pass through a defined volume over a specific time. For example, the system might capture a measurement of 7 CO2 molecules being carried upward towards the atmosphere by an eddy. Then in the next moment, only 5 of those molecules are recorded traveling back down towards the ground. Then we know that the net flux over this specific time period is equal to 2 molecules of CO2 being emitted into the atmosphere. It isn't your everyday eddy that compiles this stuff. Eddy covariance data is collected by individual researchers and organizations around the globe, including the National Ecological Observatory Network. And what's really cool is that all these institutions contribute to an international database, FluxNet, to facilitate the use of eddy covariance data to contribute to global models at many times scales. Eddy covariance measurements are really important because they're the most conclusive method for measuring how much CO2 and other gases are taken in by photosynthesis, and also emitted into Earth's atmosphere from things like respiration, geologic emissions, thawing permafrost, and human activity. Documenting these gas exchanges is important to understand trends in atmospheric concentrations. They allow for the development of accurate models to forecast greenhouse gas concentrations and other factors of climate change on our planet. So next time you think about how scientists measure CO2 and greenhouse emissions at a local level, just remember Eddy. Eddy covariance. Eddy covariance and other data are freely available at neonscience.org.
All right, there you go. Eddy covariance. So now you guys know how all of this gets measured, which we thought was quite interesting. So these are the graphs that, and if you want to read them, Jen?
Yes, ma'am.
All
I
right.
certainly do. So let's take a look at the purple. All that purple in the northern hemisphere there, that is basically anything that is tundra related, right? You know, permafrost related. So that includes all of Siberia, Greenland, northern Canada, Alaska, etc. So this figure shows us the chamber sites. There was a lot of chat about the chambers and the towers and Rapunzel, Rapunzel, let down your hair. It was going pretty wild in there. And the eddy covariance sites. So they're marked here
Yes.
on the graph, but you can kind of see what's going on and what type of methane is being emitted from the wetlands. And let's take a look at the graph on the right. So this one essentially has two types of lines. It's got dark blue lines and it's got yellow lines. The dark blue lines are the methane emissions coming out of the wetlands. If you look at the declination of the slope, the trend is up. This graph goes from 2002 to 2021, so about a 20-year period. So over this last 20-year period, the emissions from wetlands is steadily climbing. It does look to be pretty cyclical. If you got that graph, it's a bounce, but the overall slope is up. And then the slope of the wetlands that are available, linear regression of wetland area, it's going down. That means there are less wetlands, but the emissions from the wetlands are going up, net.
and it measures in teragrams. That's
Right.
the unit of measurement, and that's
Right.
the emissions are typically what I think was 535
So
teragrams a year, which is the largest natural
that's huge.
source of wetlands. Yep,
That's
predominantly at the
huge.
high latitude at
Yes.
115. So yes, we were doing our homework, guys. Yeah.
All right. Well, let's go ahead and get moving here. So, what the new model is uncovering, researchers are finding that methane emissions in the region have increased over time. They've also found that higher temperatures and increased plant productivity are the biggest drivers of the increased methane emissions in the region. When plants are more productive, they increase the amount of carbon in the soil, which acts as fuel for the soil microbes that produce the methane. By improving scientific understanding and the ability to project greenhouse gas emissions, researchers can more accurately estimate temperature increases in the future, Chen says. The team hopes to apply their model on a global scale, a task which will require wrangling a much larger data set.
Yeah,
And
and
that from the University of Wisconsin,
that's right.
Madison.
And
That's
this
right.
was the nature climate change, boreal Arctic wetland methane emissions modulated by warming and vegetation activity. And what I wanted to do was just go down and tell you, read this part, the main part, which says the methane, which is CH4, contributes approximately 20 to 30% of global emissions related radiative forcing. Remember, radiative forcing, what comes in,
Mhm.
what goes out. And
That's
is
right.
the second largest source of current anthropogenic warming with a global warming potential 28 to 34 times larger than that of CO2 over a 100-year time horizon. Now, wetlands are the largest and most uncertain natural source of CH2, global CH4. And wetland CH4 emissions are closely linked to temperature, and that is why these young people here are finding that they need to have new research, and which is showing that there's a little more methane in this instance, right?
Mhm.
All right. But now we're going to move on to Arctic lakes, which say, oh, Arctic lakes produce less methane than previously thought. What do you think of that one, Jen?
Well, maybe
Here
it's
we
good
go.
news.
In the realm of greenhouse gases, methane stands out as a significant contributor to its abundance and potent heat trapping properties, about 25 times more potent than carbon dioxide. With the Arctic being the fastest warming part of the globe, understanding methane emissions becomes crucial. It's the focus of the study at Brown. They use satellite and airborne imagery from NASA to provide new insights into methane emissions from Arctic lakes and wetlands, which were previously largely unmapped. I was really surprised. Contrary to earlier research estimating that these unmapped lakes contribute around 40% of the region's methane emissions, the current study found that small, unmapped lakes contribute only about 3% to the overall emissions. So, new insights. The high resolution imagery allowed researchers to more accurately estimate the area covered by the smaller lakes, revealing that they are more significant emitters per unit area than previously thought. So, what the research has shown is that these smaller lakes are the greater emitters of methane on a per area basis, which means even though they take up a small amount of the landscape, they have a disproportionate level of emissions, said the lead
Mhm.
author, Ethan Kisviet, a postdoctoral at Brown. The study challenges close to 15 years of research based on older data sets with lower resolution quality, which had overestimated the number of small lakes and their cumulative methane emissions. Unexpected findings. The focus of the study was on small lakes, roughly a tenth of a square kilometer or smaller. The research team, including Brown professor Lawrence C. Smith, analyzed a high-resolution airborne data and a global map of lakes in the Arctic region to produce more accurate estimates. The study revealed fewer small, unmapped lakes than previously thought, leading to a significant reduction in the cumulative methane emissions attributed to them. The unexpected findings also included the discovery of double counting of lakes as wetlands, affecting methane emission estimates. So, what are the implications? Well, furthermore, the study may help reconcile the long-standing discrepancy between bottom-up estimates, which model emissions based on Earth maps, and the top-down estimates, which use the atmospheric measurements. The improved satellite resolution now allows for a closer estimation of methane emissions, potentially unifying these two approaches. The experts see this NASA-funded study as a proof of concept and plan to expand their methane modeling technique to other regions. The next step is to go global, Kavizat concluded. We're going global. More about methane.
Boy.
And everybody knows methane's the potent greenhouse gas. We don't have to go through all of this because we've done that. But it has a shorter atmospheric lifetime than carbon dioxide, lasting about 9 to 12 years before breaking down. But it means that reducing it can have a rapid and significant impact on mitigating global warming. And there's a lot of efforts going on. But the actual research was it. A closer look at the effects of lake area, aquatic vegetation, and double-counted wetlands on pan-Arctic lake methane emissions estimates. So it's pretty good stuff. It'll all the links will be in the show notes. All right.
Mm-hmm.
Now we have another. We actually have a lovely intermission right now. This one we're going to play has to do with Boulder.
Yay, Boulder!
and we love Boulder. So
Yay, Boulder.
Yeah. So we thought this would be a lovely intermission for us to have because, every now and then it's good to do that and stand up and stretch. I think you guys are going to love it.
My name is Ava Hamilton. I'm Arapaho. I live in Boulder. This area is a very, very beautiful area, and I can understand why people want to live here. It has berries, plenty of animals to eat, and clean water. Native peoples, we are told that we are charged with caring for the earth because it's our mother. It's where we come from. Some of the knowledge that I've heard from other Indigenous people is, thousands of years old. So those sorts of knowledges are equal to Western sciences. Part of the knowledge that I've received from our Indigenous elders, some of our tribal people, is that, don't disturb the earth. And that's pretty much all we've been doing is disturbing the earth. Humans really need to live in harmony and to respect all life as much as they respect humanity. We're all related. We're not separate. Nothing is separate. Our earth has a voice. The winds, there's fire, which, has a very big voice, especially around this area. I have the right to tell this story, but I'm only going to tell a part of it. Is that once at a place just like this, there was an abundant world. There was all the food we needed. Everything we needed was there, but we didn't take care of it. The same thing that is happening here on our dying planet happened at that place. So our Earth is speaking to us. Our planet, our mother, is dying, and we're the ones responsible. We need to do more loving.
So there you have it. I thought that was a really lovely intermission, and she had a beautiful message, and she told us the truth. And she's in Boulder,
Yeah.
Jennifer's home.
She was sitting over by the National Center for Atmospheric Research, which is NCAR, and that is built
Yeah.
into the Boulder foothills, and it's very, very beautiful over there. It's quite
Nice.
lovely.
You live in a great place. You're
Yeah,
like the
it's
hub
gorgeous.
of science of ice and Arctic. So Jen, we're going to move on. We've got Thoman, Rick Thoman, and this is Jennifer's specialty. So
Oh.
take it away. Well, Arctic sea ice update, extent, ice, everything, all here from March.
All right. Yeah,
Right.
March 2024, Arctic sea ice update. Sea ice extent for the Arctic as a whole has most likely reached the maximum extent for the season. This was published on March 26th, so about a week and a half ago. While the ice extent near Alaska is still flirting with the highest level for spring 2024. Arctic sea ice. Sea ice extent in the Arctic has very likely reached the maximum extent for 2023-24 cold season. The 5-day running average extent from the National Snow and Ice Data Center preliminary peaked at 15.01 million square kilometers on March 14th and has since fallen for more than 150,000 square kilometers, I guess, until now.
Yeah.
Figure 1 plots the annual maximum extent each year since 1979, and we can see that is going down over time. Figure 1 plots the annual maximum extent each year since 1979. This brought the highest maximum extent since 2020. This year brought the highest maximum extent since 2020 and more than 300,000 square kilometers above the 2014 to 2023 10-year median. So, yeah, we are a little bit up in the Arctic, but then again, this is a little bit kind of cyclical. It has a bit of a bounce to it. So that's probably a temporary increase.
It's a bounce.
The trend, yeah. The trend over the past 46 years is clear, with the typical maximum extent now more than 10% lower than the early 1980s. The maximum Arctic ice extent is determined by ice in the marginal seas. In other words, the Sea of Okhotsk, the Bering Seas on the Pacific side, and the Arctic and Barents Sea, the Baffin Bay, Greenland Sea on the Atlantic side, with the entire central Arctic basin having 15% or higher sea ice concentration. The model ice thickness for March 2023 from the Danish Meteorological Institute, DMI, for this year, that's the picture on the left, and the same date last year, the picture on the right, as I noted last month's sea ice update, northwest of the Canadian Arctic Islands, there is much less ice that is 3 meters or more thick this year compared to last year, and a total modeled ice volume in this framework remains lower than at any previous 4 years. So net, what he is saying is that the red and the yellow is much, much less than it ever has been before. So even if you look at March 2023 and compare it to March 2024, there was more last year than there is this year in terms of sea ice thickness.
Right.
The age of the Arctic sea ice product shows how stark the picture is this spring. Figure 3 shows the analyzed sea ice age in years as of early March. First-year ice is much more susceptible to disruption and melt by summer storms and wave action. The band of 2- and 3-year ice east of Greenland is being transported out of the Arctic and is destined to melt in the North Atlantic in the coming months. So it's being transported right down the eastern edge of Greenland and washed out. And it's kind of beautiful, though, isn't it? You know?
Yeah, it is, but it's it's going. Oh,
It's
my
going.
God.
Sea ice near Alaska. I had expected to be able to report that sea ice in the Bering Sea reached its maximum extent for the season last week, and that might well be the case, but not definitely. Figure 4 shows March 18th sea ice concentration analysis near Alaska from the National Weather Service Alaska Region Sea Ice Program, which so far at least is the farthest south extent of the ice edges in Alaskan waters. And if we look at this graphic, you can see that the sea ice is reaching well through the Bering Strait. There you go. After several days of stormy south to southeast winds from the Pribilof Island westward turn north after March 23rd and push the ice edge to the south, Figure 5 plots the daily extent from the National Snow and Ice Data Center's Sea Ice Index, version 3, through March 24th. The Sea Ice Index is a 5-day running average. In other words, the value for March 24th is the average of March 20th through March 24th. So the sea ice lags the daily analysis, that sea ice average, okay? In any case, the 2024 maximum ice extent is sure to be well below the 1991 to 2020 average maximum. And you can see that that median 1991 to 2020, a 30-year average, is the black line. And this is very solidly below the black line. And we are the blue.
And wiggly.
We're wiggly. We're very, very wiggly. You know, we like to be that way.
Yeah.
The good news is that the cold weather during the first half of March thickened ice in the southern Beaufort Sea. Figure 6 shows the combined SMOS cryostat 2 sea ice thickness product from AWI for the week ending March 21st. Based on this multi-satellite drive product, ice thickness was typical to below the 2011 to 23 median in the Beaufort and eastern Chukchi Seas. Ice in the southwest Chukchi and Bering Seas was mostly thicker than usual, with important exceptions for the Norton Sound and the northern Gulf of Anadyr. So there you go.
So thickness, extent, volume, he's covering it all.
He's covering it all. Yes, it's very nerdy. And that is pretty much it. That's it.
Yeah, he covered it all.
He covered it all.
And that's what's happening in the Arctic, folks. That's what's happening in the Arctic. We wanted to do an update on the Arctic sea ice and extent and thickness, and there you go.
Yeah.
And then we've got one more. And
Tell us about it, Sandy.
Yeah, this is that. Now, I'm sure you guys heard of this article. This was the polar vortex spinning backwards. It happened, but, here we are today. So we're going to talk about that above the Arctic after the major reversal event earlier this month. A sudden atmospheric warming event caused the Arctic's polar vortex to reverse its trajectory. The swirling ring of cold air is now spinning in the wrong direction, which has triggered a record-breaking ozone spike and could impact global weather patterns. See, there it is. I actually have this in a bigger GIF. I had made a little video with it. The polar vortex circling the Arctic is swirling in the wrong direction after surprise warming in the upper atmosphere triggered a major reversal event earlier this month. It is one of the most extreme atmospheric U-turns seen in recent memory. In the past, disruptions to the polar vortex, which is a rotating mass of cold air that circles the Arctic, have triggered extremely cold weather and storms across large parts of the U.S. The current change in the vortex direction probably won't lead to a similar big freeze, but the sudden switch up has caused a record-breaking ozone spike above the North Pole. The polar vortex is most prominent during the winter months and extends into the stratosphere, the second layer of the atmosphere, up to around 30 miles, 50 kilometers above the surface. The vortex spins counterclockwise with wind speeds of around 155 miles or 250 kilometers an hour, which is around the same speed as a Category 5 hurricane, according to the UK Met Office. A similar vortex encircles Antarctica during the southern winter. So polar vortices occasionally reverse temporarily. They can last for days, weeks, months, and they are caused by sudden stratospheric warming when the temperatures in the stratosphere climb by as much as 90 degrees or 50 Celsius in the space of a couple of days. So this is what it looked like. The sudden warming, is caused by planetary waves in the atmosphere. Compression waves formed when air rises into the region of different density and is pushed back downward by the force of the Earth's spin. It reverses the vortex flow. So this tells you all about atmospheric waves, this article. So if you guys want to know more about the atmospheric waves and how this happens, it's quite interesting. It's interesting stuff. Look at those gravity waves in the atmosphere. And this is gravity wave clouds. Fascinating, isn't it?
It is.
I think that, and you can see, to clarify, that atmospheric or oceanic gravity waves are not to be confused with gravitational waves, the outward propagating perturbations in space-time that are associated with cool physics graphics, and apparently any and all Google searches on either subject. So that's what we have. And that's what
we haven't finished the article.
Did you want me to read this whole article?
Yeah, we're almost done. You want me to finish it up?
Yeah.
The current reversal event began in the Arctic on March 4th.
Yep, there we go.
However, the winds are starting to slow down, hinting that the vortex will return to its normal trajectory soon, spaceweather.com reported. It was a substantial reversal, Amy Butler, a climate scientist at the National Oceanographic and Atmospheric Administration, NOAA, and the author of NOAA's new Polar Vortex blog, told spaceweather.com. The speed of the reversed winds puts the event in the top 6 on record, she added. Disruptions to the polar vortex can impact the weather in the U.S., such as in 2019 when a massive cold front descended across the Midwest. These extreme weather events occur when the polar vortex deforms the jet stream, an air current that surrounds the polar vortex, exposing the lower latitudes to large blobs of icy Arctic air. This month's disruption did not change the shape of the jet stream, so weather patterns are expected to remain largely unaffected, according to spaceweather.com. However, the change in air temperatures around the Arctic has sucked up large amounts of ozone from lower latitudes, creating a temporary ozone spike, the opposite of an ozone hole. Currently, there is more ozone surrounding the Arctic than at this time during any other year on record, according to
Wow.
spaceweather.com. However, this ozone spike will disappear after the polar vortex returns to normal. The current reversal is the second of its kind this year, followed by a smaller event in January that did cause a brief cold snap in some states. Historical records show that the south-southwest events, or sudden stratospheric warming events, are more likely to occur during an El Nino or La Nina, the two contrasting phases of natural cycle of planet-wide warming and cooling. During these phases, global weather systems become more unstable, which sets the stage for more frequent reversal events, Butler wrote in the NOAA blog. We are currently in the midst of a major El Nino, which could make further reversals or disruptions more likely over the next year.
Isn't that
or
wild?
so.
And I'm
Yeah.
sorry, I knew that we didn't finish. I got all excited over planetary waves. I was like,
Yeah.
really want
Why not?
I know. I was like,
course.
should we do that one? It
It's
was
very exciting.
It is. So I think we've done. We're pretty much done with everything that we set out to do. Now, I think what would be great is if we have a little interaction with our chat. How's that?
Yeah.
All right,
That's
guys.
right.
I don't know what you've been talking about, but it's been a while. So let's see if I've saved
Well,
any.
somebody wrote, has the clathrate gun gone off? And I don't think that either of us are qualified to answer that question. But what we can tell you is the Arctic keeps warming and the methane emissions continue to increase. Whether the quote clathrate gun has gone off, hard to say, but more methane is coming out of the substrate, and the methane hydrate is coming out both in the wetlands and in the Arctic Ocean.
And there is newer research that's Similatov and Sarkova had done. That was, I think, last year, but most of the citations are it's Russian, but they had discussed and Drew Void is Yin Yang knows. I didn't bring it up, but they were talking about the seepage in the ocean floor. So, but I don't have that research. I did not read the whole thing. So, well, let me think. 3 people. All right, there's 3. Thank you. You know, Obsolete Optics bought 50 memberships.
Oh,
So people can
that's
join
so
our channel.
sweet.
I know.
That's so
And
sweet.
I know it's very nice. And
Aw.
all right, so that was Devon who had brought up the question about
Yeah,
the clathrate.
she
There, I
did.
found it. Okay,
She did.
and Nadia, is the clathrate gun firing too now? Reddit said it was 4 years ago in a post by Fins T quoting Igor Similatov. That's there's talk of people seeing big bubbles in Laptev and East Siberian seas too. We've talked about this many times, Jennifer and I. We've
Yeah.
done shows
Yeah.
on that. We have shown the pingos. We've shown all of this, but there's
We've shown it all.
Yeah, there's not definitive 100%, Nadia. I mean, it's not happening overnight. It's not happening where we're blowing up. It's not. And
Yeah.
thank
Stay
you.
tuned.
Yeah, Looney Tunes. The 2024 hurricane season fired for the Atlantic is not looking good. And that scares me for you. I know you live in Louisiana. So we have to, we all have to get ready for all of this shit that's happening. I mean, today here at my house, just for example, I know it's April. It's happened. It's snowed here before. It was up and down all day. It went from snow to melting to sun to hail to snow to rain to ice. I mean, it's up and down all day, Jennifer. It was wild here.
Wow.
Literally, I took videos of the hail. I didn't put them in,
Oh my
but the
God.
hail was like it wasn't big hail like I've seen in other places, but it was pretty wild. I thought, holy
Wow.
shit! I'm
That is
like,
pretty
what the
wild.
heck is
Okay.
going on with all this hail?
Have you
And
planted anything yet, or is it too
in the
early?
house, I haven't done anything
House.
outside. I am so slow this year. I'm behind on everything. No, I've got flats. I've got Brussels sprouts, cabbage. I've got cool weather crops to go out. I haven't done anything. I haven't done
Hmm.
anything much outside. I'm okay. I'll get it done. It's only me, you know. I mean, there's a lot to do. But yeah, I've got the flats going, but nothing outside. And usually I don't have anything outside in April because it's so
Hmm.
iffy. And remember
Yeah.
last year I had a freeze in May and I had to run outside. Remember last year, Jennifer, I showed you the picture with all the sheets on my orchard trees, the turquoise sheets. 'Cause
Yeah, yeah.
yeah. And we are now a temperature zone, a planting zone. We used to be 5B, I think. Now we're 6. It's changed.
Really?
Climate change has changed. Yes.
My goodness.
Yep. Yep. So what are you doing with yours? You're outside this year.
Well, I have just been bringing the garden back to life. It was, we got some heavy snows, but then it got very dry. So it's going to be pretty windy here. There's fire warnings just because it's so windy and dry.
Shit.
And, you know,
Did you get enough
it's like
snow that
the
it's
West.
gonna? It's not.
I think so because we got a couple of really good dumps lately. So I think
But
we're
it's still
probably
dry.
okay.
It's still
It,
dry.
it's amazing how quickly it dries out. That's the thing.
Damn.
Yeah.
That's scary to me,
Yeah.
anyway.
Yeah.
So everybody's talking about the eclipse.
Oh, yeah.
I had a funny meme and I didn't bring it up. Shit. I thought I would do something on Sunday before Monday, just
Mhm.
a little something on Sunday for you guys. I don't know yet, but so Devon and Dan, Natural History and Truth. Hello, it's nice to see you too. Welcome. Tommyist, hello. And Channel Warhorse. Lightning Rod, what are you saying? There's a guy in Canada growing bananas in Canada, in Alberta in the winter. No shit. Oh my gosh.
What?
Really? Wow. Now, if you paint your house blue, the eclipse won't hit you.
Oh my
Who
gosh.
gave you that
I didn't
idea?
have that at all.
Marjorie Taylor Greene probably said that.
Gosh.
There was also the earthquake in New York City. And on Twitter, there's a lot of hilarious jokes, about it. But she said it was God's, it was God is getting back at us, or it's for we need to be redeemed, or for redemption, or some bullshit like that. I'm thinking, well, wait a minute, wouldn't it be the opposite for a snake oil salesman selling Bibles?
God.
Because the earthquake hit near his golf course in New Jersey. Oh my God. She is,
Yeah.
yeah, you're not going to get hit with it in the West Coast. But a lot of people are saying, Jennifer, okay, when the
What?
eclipse goes through, everybody's going to be looking up what's really going to happen when we're all looking at the eclipse. And then think of all those fucking glasses. Everybody and their brothers buying those cheap plastic glasses. Where are they going to end up?
In the trash the next day.
Yup, in the landfill, probably not even recyclable, right? Yeah,
Probably not.
gotta love those snake oil salesmen, Bible sellers. All right, listen, I just found the flush of the day. The flush of the day. Snake oil salesman selling Bibles. Nothing to do with our show. All right.
Very funny.
Oh yeah, she's in New York and she didn't feel it. But
Oh,
people did.
Nadia.
People
Nadia.
did. Yeah. So what else is going on, guys? I'm looking. Yes, she said, yep, we did the flush. Well, I think Jennifer, we're almost an hour. We covered a lot. I mean,
We sure did.
And we taught you about the measurements, the way that we show the video of how the scientists measure different kinds of gases.
Mm-hmm.
And you talked about the Arctic ice. I think it's been fun, and I'm glad you came.
Yeah.
I'm glad you came back. I know you can't come every Friday, but you know. All right, hello, y'all. In case you haven't seen the Northern Lights in real life before we go extinct, yes, we know you. She sent beautiful pictures. I highly recommend a visit to the
That's
Aurora Borealis.
gorgeous.
Thing is, I was going to use them tonight, and I didn't get anything set up. She sent me beautiful pictures, which I hope to make something out of. Really, really. Matt, no hopium for me, thanks. This epoch doesn't even exist, they say. Right? How the scientists don't want to. The geologists are kicking and screaming, Jennifer, about not bringing us into the Anthropocene, that they want to still stick with the Holocene.
Holocene.
Yep.
Well,
And
you can call it whatever you wish.
methane blues. Yeah. Methane
There you go.
blues. We got the methane blues. I'm going to put on this adorable little music. It's fairy dust. Are we going to do some Irish
nice.
dancing on the way out? Yeah. Well, anyway, yep, CH4. That's what the show is about. All right, Jen, what have you got to say?
Well, it's good to see you all again tonight. I think we've had a pretty comprehensive show summing up the wetland and the methane problem, and then the sea ice and the polar vortex. That's weird that the polar vortex is going in the opposite direction. But, everything else is weird too. So
And they
there you
said,
go.
yeah, well, weird.
Yeah.
I should have just called the show weird.
There you go.
Yeah. All right, smile, guys, because, man, the other option is something I might never stop doing. And I'll smile tonight because I'm with my Jen, and I'm very happy. Yeah, I miss
love
you.
you too.
I miss you. I love you too. And
I
I
missed
love
you too.
all of you guys. We love all of you guys. All right. See ya. I'll be on
All right.
Sunday at some point, I think. All right, guys. Mwah.